Good day to you today, and welcome to today's episode of Chemistry with John O. Now, quickly, if you're a JAMB student, IJMB student, JUPEP student, WAEC and NECO student, preparing for the forthcoming JAMB examination and the likes, please come closer. Now, today we'll be looking at balancing redox reaction. Now this is a topic in chemistry that students dread a lot. So today we'll be looking at quick steps of balancing redox reaction. Now the question we are considering says write a balanced ionic equation for the reaction between acidified potassium tetraosomanganese 7 and iron 2 tetraososulfate. Now quickly, the first thing you need to know or do under redox reaction when you are trying to balance is step 1. You write out the first half of the equation. Now the first one will be MnO4, that's the manganate ion, and then here you know that this is the oxidizing agent. And then when it undergoes reduction, it is reduced to manganate ion. That is the first thing you need to know. So on the part of the permanganate acidified one, this is what we have. Then on the second half of the equation, we have iron 2. Iron 2 will be oxidizing, Iron 2 will be oxidizing to 3. Iron 3. Now, in this topic, we'll be adding hydrogen ion and water to balance both sides of the equation. And then, this is because acidified medium, it is in an acidified medium. We also have the basic medium. We'll be looking at that later on. Now, let's move on with what we have here. In step 1, we have successfully written the first half. This is the reduction and the oxidation half. Now, having said that, we move to step 2 quickly. Step 2. Here, like I said, we'll be adding water. And so, since we have here MnO4 ion, in an acidified medium, the definition of an acid is a substance that produces hydrogen ion as the only positive ion when dissolved in water. So that is why in this case we'll be adding hydrogen ion and water to balance the equations. Now here we know that manganate should be producing manganate ion. Manganate oxide, the manganate here should be producing manganate ion. But what are the other addition to this? So we have here plus what? I said we'll be adding hydrogen ion. So how do I know how much hydrogen ion am I supposed to be adding? Now this is a simple logic. 4 oxygen is involved here. After Mn ion has been taken. So 4 oxygen will produce how much water? 4 oxygen will produce 4 molecules of water. Now, in this 4 molecules of water, how much hydrogen atom can we get? We have 4 times 2, 8. Now, invariably, 8 hydrogen atom will produce 8 hydrogen ions. So we have 8 hydrogen ion here. Then adding, what else are we supposed to have here? Now on this side we have MnO4, so we'll be adding water. So how much water will be added? From this side we already know this and this. If 4 oxygen atom is reacting with 8 hydrogen atom, definitely we have 4 molecules of water. So we'll be having 4H2O. Are we following, please? Now, here, something is missing that is supposed to be replaced by iron. Iron is the other half, but this cannot be left empty. And this is what we do. We try to balance the ion. You know, we talk about ionic, right? The ionic. So the issue of ionic is very important. Balancing and checking out for the ions. Here we have -1 plus 8. -1 plus 8 gives us +7. So we are expected to have 7 ions here. And on this side, on the right hand side, we have 2 ions. So we need 5 ions to equate what is on my left hand side. So what do? We use an electron, we add an electron to balance up. Now this is where the ion is missing, but you add your electron to the other side. Remember that. So we have 5e electron to balance up for the 5 ion missing here. So having done that, we are done with step 2. Yes. Then quickly we can now move to, okay, we are not done. Step 2, ion. Ion 2 to give ion 3. Now, this 5, like we talked earlier, is the ion missing in that. That's the element missing if you look at the equation from the question we have. So we are supposed to balance here by 5, and then when we come here, 5. So to balance up the ion, we have 5 atoms of ion 2, 5 atoms of ion 3. But the ion, are they balanced? Let's watch out. This is 2 times 5, 10. 5 times 3, that's 15. So it is not balanced. So if we have 10 here and we have 15 here, here is deficient of 5 electrons. So it's deficient here. Like I said, we add it to the other side. So we're adding 5 electrons to balance up our deficiency. Now, this is step 2. Quickly, I move to step 3. Step 3. Step 3, this is where we are writing the overall equation of the two halves, balancing the elements, the ions, and all other things needed to be balanced. Now, this is the logic. We write everything on the left hand side and equate it to all on the right hand side, excluding the ions that was used in balancing. So on the left hand side, we have MnO4 ion plus 8 hydrogen ion plus, on the left hand side, 5 Fe2 to produce manganate. Does what? Reduces to Mn2 plus we have F, yes, M plus water, 4H2O plus this 5 Fe3 plus, and that is our overall equation. Overall equation of the redox reaction. Now, quickly, let's balance the ion on the left hand side. Let's see if it equates the right hand side and the elements all together. We have reduction, oxidation half, Now, here we have manganate, one atom of manganate here, 2, 4 here, 4 oxygen, 4 oxygen is taken here. We have 8 hydrogen. So 8 hydrogen, 4 times 2 gives us 8 hydrogen, that's balanced. 5 iron, then we have 5 iron here, also balanced. Now, the ion. Now we have here -1 plus 8 plus 5 times 2, that's 10. This gives us -1, that's plus 7 plus 10, 17. So the ion on this side is plus 17. Let's see if we have the same on this side. Plus 2, 5 times plus 3, that's plus 15, plus 2, so we have plus 17. So our equation is balanced, and this is how we go about balancing a redox reaction in an acidified medium. Now we'll be looking at how you go about when it is in basic medium. Stay tuned. Thank you.